A convex hull means a set of points are called convex. If I have any 2 points on the set, then there is an entire line segment with all the endpoints included belonging to the set. Let's say for this one, if I include a rubber band around this particular star, then not all the points are going to get included. If I include a rubber band around this pentagon, then all the points are going to get included. So that is the convex hull. Let's say here there are 2 points. If I include a rubber band here, then it's only going to give me a straight line with 2 points. All my points are not at all getting included here. So that is the difference between convex hull and not convex hull. So straight line, triangle, rectangle, convex polygon, circle, all these are convex hull. These sets are convex, so I can create a convex hull out of it. Other figures, as you can see here, the boundary of these figures and a circumference are examples of sets that are not convex. So if I take a rubber band and stretch it, then the area that is within it, that is the convex hull. So the convex hull is the set of all points that belongs to the smallest convex set that is there. So if I have 2 points, then the line segment. If I have 3 points, then the triangle is the convex hull. If I have 4 points, then I should see if a convex hull is possible or not possible. And we are going to see that using a program. So the algorithm of the program is for each and every pair, I check if the point, any other point that is there, is it lying on the left side of the line. In case if it is so, I set valid equal to false. So it is not a valid point and I come out. Otherwise, and I come out of the loop. If valid equal to true, that means valid equal to true means that point can be added to hull. So like this, if I get every point added to hull, the convex hull, then it is the right solution. So initially here I check for the orientation. I compute the cross product to check the orientation. And here I calculate on left, that is, if the cross product is more than 0, then the point is on the left of the line. So brute force, I have the endpoints. Initially hull is set to an empty set. Now for I check each and every point. If both the points are same, I check for the next point. Now initially I set valid equal to true. Now once I do valid equal to true, I will check if in the range I am checking any k or I point. Then I continue with the loop again. Otherwise, if it is a new point that is there, a new point, I will check by checking if the new point is lying to the left of ij. Then it is not a hull edge. Otherwise, if I get valid, then I add it to the hull. So hull dot add, I am adding the 2 points I and j. So now for let's say if I have these points 0 0 1 1 2 2 3 0, I get the hull as the same. Let's say if I change this to 0 0 here, see this point is not included because it is already included over here. Or let me also specify 1 comma 2. Now that point is also something which is going to get included. One one two two. Okay. 1 2 is lying somewhere in between. Let me show boundaries of a square, that is 0 0 0 1. Let me add 0 1 and then 1 0. Okay, let me take 2. 0 2 2 2. Let me put 2 0 also and 1 1. So as you can see here, 1 1 is not included because it is an extra point which is not to be included in the null. See, 0 0 0 2 2 2 2 0 form a square and 1 1 is lying somewhere in between. So I need not include 1 1 in the hull.